So it says after the recently held national sports championship, the government decided to allot some land to all the top performers in the three games: badminton, boxing, and shooting. All the top performers were allotted a piece of land from a marked area of 160 by 240 meters. Each badminton player was allotted a square piece of land. Each boxing player was allotted a rectangular piece of land, and each shooting player was allotted a triangular piece of land. So this is important that a badminton player was allotted square piece of land, boxing player was allotted rectangular piece, and shooting player was allotted triangular piece. The figure shows below the allotted pieces of land as per their shapes from the total 160 by 240 square meter land. Each small box in the figure represents a 10 by 10 square meter area. In a total, 6 badminton players, 8 boxing players, and 12 shooting players were allotted the lands, and they are marked by A to Z. Answer the following questions based on the information now. So here is the graph given to us. In this graph, we clearly say that some of the figures are in the form of a triangle, like these figures, which are given to shooting players. Some of them are rectangles, like these figures, which are given to boxing players. And some of them are square figures, like these figures, which are given to some of the badminton players. So I have to figure out that what is the area of each of these figures. That is the first thing. And second thing that we have to figure out, that is that which player is actually a boxing player, badminton player, or a shooting player. So we have let's find out first the badminton players, boxing players, and the shooting players. So I'll just keep on writing all the letters according to their names. We can easily do that. So A, because triangular, it is a shooting player. B is rectangular, boxing player. C is triangular, shooting player. D is triangular. After that, E is again a rectangular area. Then after that, I have F as again a rectangular area. G is a square, so G would come over here. After that, I have H as a triangular area. Then I have I as a rectangular area. Then I have J once again a triangular area, and then K is again a rectangular area. L is a square, so L would come here. M is, I look like it's a square. No, it's not a square. It is a rectangular area. How do I know that? So there are 1, 2, 3, 4, 5 boxes, and 1, 2, 3, 4, 5, 6 boxes. So 6 by 5 is a square. After that, N is a triangular area. Then I have I. So I'm sorry, I'm an O. O is a square area, as you all can see. O, P is again a triangular area. P, after that we have Q. So where is Q? Q is also a triangular area. Then we have R. R looks like a square. Yes, R is a square. And then S is a triangular area. Then I have T, which is again a triangular area. Then I have U is a rectangular area. Then V is a square area. And then I have W. W is a triangular area. X is again a square area. And then I have Y, which is rectangular, and Z is a triangular area. So I see 6 badminton players over here, and 1, 2, 3, 4, 5, 6, 7, 8 boxing players are there, and then 26 minus 8 and 6, 12 players are here. What about the areas now? How do we calculate the areas of all these figures? So what's an easy way to calculate these areas? That's what we have to discuss now. So please pay attention that how do we calculate these areas. For a rectangle, it is pretty easy, right? So for example, F is a rectangle. So 1, 2, 3, 4 and 4 by 5. 4 by 5, 20 would be the area. For M, it is 5 by 6, 30 would be the area. For U, it is 1 by 4, 4 would be the area. Similarly, 4 here. Here, 4 by 4 would be 16, it's a square. Here, 6 by 6 is 36, it's a square, right? And I have this also as a square, 3 by 3, that is 9. The problem would be in the triangular areas or the areas where we have a square or a rectangle, but the lines are exactly in the shape of a diagonal. So first of all, I'll talk about, let's say, B. Let's talk about B here. So what is the area of B? How would I calculate that? So just take this point here, this point as here, this point as here, and this point as here. So how do I calculate the area of B in an easy way? What is the right way of doing that? Let's talk about it. So to calculate the area of that, we can do one thing. we can make some triangles and we can see some of the complete areas that can be done. I mean, for example, if I talk about, let's say this side is 1, so 1, right? This is 1 plus 1 2 plus 1 3 plus 1 4, right? This is 4, and 1 plus 1 2 plus 1 3 plus 1 4. So it this side by Pythagoras theorem would be 4 root 2. 4 square plus 4 square root of that is 4 root 2. What about the other side? The other side is 1 plus 1 plus 1, that is 3, and 1 plus 1 plus 1, that is 3. So this side is 3 root 2. So 4 root 2 into 3 root 2, that is equal to be 24. So area of this complete B is going to be 24. Area of B complete is equal to 24. Is there any other area for doing that? Yes, there are other areas as well. I mean, there are other ways as well through which we can do this. Let me talk about that other way as well. How can I find out the area of this B? The other way is, let's count the complete boxes first. So I have some of the complete boxes: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There are 17 complete boxes. Then look at the half boxes: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 17 complete boxes and 14 half boxes. So 14 half boxes will make 7 complete boxes. That way also I can say the area of this figure is 24. That's one way through which we can calculate this. I hope you have got an idea. What about the triangular pieces now? Let's talk about the triangular pieces as well. Let's take any triangular piece. Let's say H. How do I find out the area of H? To find out the area of H, just make it a complete figure first and your job is done. What about the area of this complete figure? So can I say it is 4 by 4, that is 16. Half of that is 8. So area of H is equal to 8. Make the complete figure and take half of it. I hope you are getting this point. So that means it will be easy for you to calculate these areas as well. Or of course you can take a half of base into height as well. So base is 4, height is 4. So half of 4 into 4. So half of 4 into 4 is also 8. For example, if I have to calculate the area of J, so base is 1, 2, 3, 4 and height is 2. So half of 4 into 2. Half of 4 into 2, the area of J would be 4. So that way, I'm sure you can calculate the area of all other boxes now by yourself. I'm sure there would not be a problem for any of the areas. For example, P, you can see height is 3, the base is 6, so half of 6 into 3. K, it can be calculated just like B. G, it can be calculated just like B, and that way we can calculate all the figures. Once that table is made, the question would be very easy for us. So I've already made that table for all of you. First question, what is the total area of the land pieces allotted to shooting players? Let's have a look at this. So these are the areas that I have written in front of all their land pieces that they have. So total area of the land pieces allotted to shooting players. That means I have to add all of them. So 8 plus 25, 33, plus 8, 41, plus 4, 45, 45 plus 18, that is equal to 63, 63 plus 20, that is equal to 83, and 83 plus 10 is 93. So the total area given to shooting players is 93 boxes. Now 93 boxes, and one box was of 10 by 10 square meters, if you guys remember it. So 93 into 100 is 93 square meters. In this question, some of you might have made this mistake that while doing all of this, we would have forgotten that actually every box was representing 100 square meters. And because it was a theta, probably we would have answered 93, but actual answer is 9300. Now, this question number 12 says the land piece with maximum area belongs to a player of which sport? So, which is the maximum area? The maximum area I see is 36 here. Is there anyone above 36? No. So, a badminton player has a maximum area. So, my answer is option A. Buddies is the name given to a pair of players if the land allotted to them has the same area but they play different sports. How many buddies are there in given 26 players? So we have to find out those pairs who play different sports but have the same area. For example, is there any buddy of G? Any buddy of G who is playing a different game than badminton but have the same area? Yes, there is a buddy of G, that is Y. There is no other body of G. Is there any body of L? A body of L is P, and P is the only body of L. O will not be a body because they are playing the same game. There cannot be any body of 36 is having the highest area. O will also have the body of P, that is an area of 9. V, will V be having any body? Yes, V has a body of J. Then is 16 having a body? X is having a body? No, X is having no body. So badminton players have only these 4 bodies. Now boxing and shooting. Is 24 anywhere else in shooting? No, it is not there. Is 35 anywhere else in shooting? No. Is 20 there in shooting? No. Is 12 there in shooting? No. Is 24 in shooting? No. Is 30 there in shooting? No. Is 8 there in shooting? Yes, I see it is thrice. That means this U is a body of A, U is a body of H, and U is a body of Z as well. Is 32 there in shooting? No. So ultimately these are the 7 pairs of buddies. So my answer for this question is 7. Next question says, how many players from badminton got a land piece with area more than that of the minimum area land in boxing, but less than that of the player with maximum area land in shooting? Okay. So there should be more than the minimum area land in boxing. So minimum area land in boxing is, it is 8. So it should be more than 8. Less than that of player with maximum area land in shooting. So maximum area land in shooting is 18. So greater than 8, less than 18 in badminton. Greater than 8, less than 18 is this. Greater than 8, less than 18 is this. Greater than 8, less than 18 is this. There are 3 members. So my answer for question number 14 is option B, that is 3. And lastly, question number 15, the maximum possible difference between the area of land pieces of any two players. Maximum possible difference between area of land pieces. The maximum is 36, the minimum is 2, so the difference is 34 in 100 square meters. So my answer is 3400 square meters. That is the answer for question number 15.